more questions shortly. I'd like to welcome Cheryl Hillman, because I think what's so interesting about the conversation we've just had, we're all trying to work with, well, new materials. Are they acceptable within the population? Are they acceptable within the building code? And how does one actually resolve those? So I'm going to leave it to you to introduce your panel.
I don't know where my panel is. We've lost them. Wolf and Ghislaine and Mbuse. Hi. 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 We're missing one. He's there. He's coming. Okay, so I believe we're running late and we're short of time, so we're going to try and make this as quick as we can, given the amount of material we need to get through. Hello. We've heard a lot in the last few days about sustainability, particularly in the affordable housing space. And I think, given we heard about the need for an appropriate material, construction material, and given that conventional construction methods are not only have a significant environmental impact, but we require something or materials that have a faster build and are lower cost if we are to address the worldwide housing shortage. So this is something at Citra. I'm from Citra Development. It's a topic that's very close to our hearts because we are property developers, but we have also developed our own alternative building technology that we use to roll out affordable housing. But I have a panel here of 3 equally experienced people in alternative building technologies, so we're going to go right into it. I'm going to give you a chance to introduce yourselves, so I'm going to start with Wolf. Can you tell us what your company does, and also the environmental benefits of your product?
Absolutely, Cheryl, thanks. And good morning, everyone. My name is Wolf. I'm the founder of Easy Housing. And Easy Housing is a circular and bio-based building concept. And what that means practically is that we have a prefabricated timber system using sustainably sourced timber from sustainable forestry in the countries that we operate. So we are building sustainable, affordable housing in Uganda, Ghana, and actually this week we started our rollout to Kenya, so that's very exciting. And I think when it comes to material innovation, when you talk about timber housing, some countries around the world are very familiar with it, like in the States or in Scandinavia, most residential homes, buildings are actually built with timber. But in other countries, like in Uganda where we operate, we are the first one to use sustainable timber construction. And that requires, of course, a lot of awareness raising and addressing misconceptions and so forth. While if we look at the environmental and social benefits of timber construction and prefabrication, they are huge. Through using timber, we actually stimulate the local sustainable forestry sector. So there's a lot of spin-off value, like that demand drives the plantation forests, it drives those rural green jobs which are so needed in countries like Uganda. And of course also all the environmental benefits of these forests being around. So that's the first thing I would like to state from an environmental perspective. Building with sustainably sourced timber actually increases forest area because you increase the economic demand for plantation forests. So it's a great way of driving the forestry sector, and at the same time using timber in the built environment creates long-term carbon storage, because those trees that have been harvested sustainably have captured CO2 from the atmosphere, stored it into their own wood, and then using that in the structures creates a huge amount of CO2 storage in the built environment. And that storage potential is one of the other huge environmental benefits of building with timber. And yeah, what we do with Easy Housing is basically introducing our own approach to prefabricated timber, bringing the benefits of factory production, quality control, and prefabrication, which yields fast construction cycles and high levels of quality and safety control as well. I'll leave it at that for now.
Great. Mabuse, we're going to move to you. Hydroform, which I believe uses 70% less mortar in your build. Can you tell us about your product and also the benefits of your product?
Thanks, Cheryl. Thanks also to the AUHF and ISMMA for having us here. Glad to come back again. I think we were here last year, so congratulations to AUHF for 40 years anniversary this year. My name is Mabuse. I'm from Hydroform, a proudly South African company, which has been around for the past 36 years. We basically have developed technology that produces interlocking compressed earth blocks. Hydroform is the OEM, is the original equipment manufacturer. So any other Hydroform product that's out there that's not from South Africa is not a real brand. So I just wanted to make that clear. But what our technology does, we're basically using natural resources, local soil content that's available on the continent here, on the South African, on the African continent. We basically compress this in one of our machines, and it's designed in a way that it interlocks into each other. It interlocks on the top, bottom, and both sides as well. By using the natural resources, the whole concept basically comes from the old mud houses that we used to use on the continent. And by just mixing it with just about 10% cement, which is the binder, to make sure that we have the sustainability, the durability of the product so that it lasts long. And also it has a quality finish to it as well. And then a bit of water. You then don't burn the brick. You cure it by just putting a bit of water for about 8 days, and then you get your maximum MPa strength. We like to recommend from South Africa perspective in terms of our standards, a minimum is 7 MPa, but I know in the rest of the continent you can do with about 4 MPa strength, but in South Africa we work with 7 MPa. From there you're able then to start construction using the interlock method, and the block just interlock into each other, and then achieving speed of construction. And again, by using the local content, you can also employ local skill, local community members, local youth members to build using their own products. This way, we train them to be able to be skilled up into using the product themselves and understand how to do it. Okay, sorry, the video was supposed to play before, but that's one of our products that we, for people who haven't seen it, that's our M7 M1 Super that we use to basically build the blocks. And all this is manufactured in South Africa. If possible, can we just go straight to the next video? I just want to show the interlocking side of it. This is how the blocks basically interlock into each other without mortar joints. This is what Cheryl was referring to, that in our structure, we have dry stack, so less cement in between the blocks. That's why it's easy to train somebody, unskilled labor, to do their own construction with this. Yeah, I'll leave it there for now as well.
Great, it's very exciting to see what you guys are doing. Ghislaine, you're doing something very exciting in the industry, very tech-based, which is 3D printed houses. I mean, that is just, it's a game changer, I'm sure.
Yes, hello everyone. Thank you for having me here today to talk about innovative material. I'm Guilain Lamarck. I'm a country manager for 14 Trees in Kenya. 14 Trees is a construction tech company specialized in 3D printing. We began our journey in Malawi, where we 3D printed the first house in Africa and the first school in Africa. Then we scale up our activity to Kenya. We have printed the first IFC Edge Advanced certified buildings 3 years ago. We are busy with some affordable housing project in Kenya as well, in Kilifi, on the Kenyan coast. And I have a question for you. Who is familiar with 3D printing here in the room? You can raise your hand. Who knows the process of 3D printing? I see some hands at the back. Yeah, so like basically like 10-15% of the people. So let me explain to you the technology. I try to be short. Construction 3D printing is basically the same concept than plastic 3D printing that everybody knows. You create an object by layering material on top of each other. So you have a big machine, 15 meters by 15 meters, and this machine will extrude some material, okay, and a layer of material, then it will go up, and the second layer of material, and the third layer of material, until you create from bottom up until you have a structure. So basically the walls of the house, okay. So the process is fast. You can print, 3D print a 100 square meter house in 2 days, 3 days today. We were talking about innovative material and environmental impact, right? So the benefit of the technology is the material consumption. The main benefit is the material consumption. Thanks to the technology, the printing is computer guided, so you will extrude the exact quantity of material at the exact place. So we did the calculation, and if you compare 3D printing with concrete block walls, we use 40% less material than concrete block walls. It's massive, okay? The second thing is, in terms of material innovation, is today most of the companies are printing with concrete or mortar printing, but a lot of research are made in finding new material, alternative material using less aggregates or alternative aggregates such as like recycled concrete or recycled glass to replace the sand, for example, and also to replace the cement, which is, everybody knows it's like a highly emissive in carbon. Replace the cement by local soil or clay printing, and we create mixed design that are basically greener, and we can print greener. Yeah.
And I mean, all these processes we've just heard, some are faster, some are more cost effective than conventional. There's also the other, I mean, I think it was Paul who spoke about sustainability is not just environmental, you know, it's the economic and social benefits. And Mabuse, you spoke about job creation. You get the additional impact for the end user of the product. If the product is thermally more effective, they're going to have a lower heating and cooling costs, and also the cost of their house is going to be more affordable. So I think it's great. We know all the benefits, you know, but the challenges. Now, I mean, your product, Ghislaine, is really out the box. So you must have faced some significant challenges when it comes to building regulations.
Yes, actually the building regulations depends a lot on the country and the local authorities, like willing to push a technology. I can give two examples, South Africa and Dubai. In South Africa, there is a massive housing crisis there. And the 3D printing could be like a technology, one of the technology to solve this housing crisis. Okay, but the problem is we don't have willing from the government, and to change the building code. So today's even some 3D printing companies try to start in South Africa, and they had to stop their activity because there was a blockage. Okay. At the opposite, you go to Dubai, the municipality has declared 2 years ago that 25% of the construction should be 3D printed by 2030. 25% in Dubai, it was 2 years ago, so 8 years to reach this target. And this is massive. I don't know if they will success and they will reach this 25%, but at least you have a creation of a momentum in the industry and a magic cycle, a virtuous cycle. So when you have like a willing from the local authorities, from the government to change the rules and create a legal framework, create an ecosystem around a new technology or innovative material, you will accelerate the development of the technology, you will inject some cash, and it's a virtual cycle. So the technology will be more affordable, will be more reliable, you will build faster, you will build cheaper, and then the cycle is starting. So the first thing is willing and to integrate one innovative material into the building codes. Then after it's only testing and making sure that the technology is technically feasible and respect the building standards.
So I think, Mbuse, let's talk about testing and the need to develop standardized testing and certifications, certification procedures for these kinds of building materials. What was your experience?
So we got accreditation with ISMMA in South Africa, which is the authority body that does the approvals for all the alternative building technology. So we got ours, we were one of the first companies to get the approval in 1988, but it was not easy. There's an investment cost that goes into it, and as a startup company, most of the time you don't have that kind of capital to pay for such tests, which is, example, they'll be doing fire testing, weather resistance, water penetration, structural integrity, durability, earthquake testing. All of those simulations cost money, and you have to pay for yourselves upfront as a startup in a company. And I can fully understand what Ghislaine is saying, that it's difficult to enter the market if you don't have that, because government sometimes has to come to the party. And I think for us, though, we have seen now recently with our South African government is that they've started engaging directly with the likes of Hydroform to say, come to the party, let's write up the policy and the standards to put together on how we should address alternative building technology. It's still a bit of a challenge in terms of the rest of the African continent, but I believe sessions like such as these that allow us to communicate and talk about this, get us invited into different countries to come engage with different governments and say and give direction and guidance in terms of how we should go about setting up these standards.
That is fantastic news. I'm really excited to hear about that. And then I think, Wolf, from your side, challenges in rolling out prefab timber in terms of building codes and testing and gaining accreditation.
Yeah, thanks, Cheryl. Interestingly enough, for us, we don't have much issues with building codes because timber or timber frame construction as a building method has been around for a very long time. The oldest timber structures in the world are over 1,300 years old and still in good shape. And a lot of the building codes in the countries that we operate in have either been based on the UK code or Euro code, which have an extensive section on timber construction. So in that sense, our challenge is not so much in the building codes themselves, rather in finding or building the ecosystem of expertise needed when it comes to structural engineers, architects, and all other building professionals that have to be acquainted with timber to be able to understand the permit drawings and the structural details. So in that sense, it's more building the knowledge, like integrating it into education curricula at universities and so forth. The other part of like where we are innovative with Easy Housing is more on the digitalization aspect, like fully digitalized models that allow us to prefabricate, which is not a barrier for building codes. And another thing we innovate in is, for example, the circularity of the technical details. So ensuring that every part of the building is demountable, reusable, can be relocated, incrementally expanded, and that circularity is not a prerequisite in building codes. It should be, but it's actually an advantage that we bring. So looking at building codes themselves, I think they're quite well addressed for timber construction, maybe not so much for other bio-based materials like bamboo or maybe bio-based insulation like hemp insulation or other types, which are also important. But I think most critical is building the ecosystem and the expertise around nature-based solutions at all levels of the housing and construction value chain. And then, in my experience also in rolling out timber construction in the Netherlands and into Uganda and so forth, is that the clerks that actually have to stamp the permits will not be the hurdle, as long as the rest is in order, basically. Yeah.
Okay, and I mean, one of the other challenges we find, especially when you start rolling out, in the early days, is market acceptance. How have you found market acceptance of your product?
Yeah, that's a very important part as well of the work that we're doing. There's a lot of thought leadership and advocacy involved. What we do in the countries that we start in, like Uganda, Kenya, there's a lot of advertising and engaging in interviews, in having conversations with people on the ground. I think the advantage we have is that our product looks beautiful, so people are interested in them. So we do find a lot of traction in Uganda. In Mozambique, we also tried, and we found it very hard to find customers. So I think it's also very country specific. In Uganda, we have quite a lot of customers coming in because they like the concept, they're interested in the innovation and in the sustainability of it, and we can be cost competitive in Uganda. That's also an important part of the success. But I've also seen this transformation in the Netherlands and in Western Europe over the past 10 years since I started in trying to propagate bio-based construction. And interestingly is maybe you hit cultural resistance at first, but if you and other players in the ecosystem are advocating it enough, if the story makes sense, the narrative, which it does in our case, within a few years the mindset can really change and you can actually push that transition, being a pioneer in it. So I think that's an important role we have as innovators in material innovations, whether it's timber or the other ones.
Yeah, and I think the other thing about products like this is there's a lot of money, and I think you spoke to that, that goes into research and development, and the initial startup costs are quite high. And for you've rolled out over 70 countries or something. So how did you ensure that your quality remained consistent through that process?
Yeah, it's a very, very challenging part that in the beginning we had some serious hurdles, because what we would do is manufacture a product and sell it into the country and trust that the owner of that product will do the quality job. And we soon realized that that doesn't work, because then that tends to be individuals who want to take shortcuts. So the research is there for a purpose. When we say you have to cure for 8 days, it has to be for 8 days, because then you get your MPA, your correct MPA strength. So what we do now is make sure that as part of the delivery of the equipment in each project that we work in, is we include training, on-site training, and we also make sure that we've got project site management as well to partner with whoever we're working with. So depending on the type of project, we scale the cost for that, obviously. But also, at the end of the construction project, now we issued with an endorsement certificate to say this was a quality product done by Hydroform together with the client, so that should anyone come back and say there's issues with this, then we have correctly gone through it. And again, we will make sure that we work with the local professionals, the structural engineers, architects as well, to make sure that we achieve the right standards according to the local country. But also the other challenges that we have as a local manufacturer on the African continent is that we face a lot of fake products that's coming from, especially the eastern part of the continent, of the globe. And I'll say it out, it's Alibaba. You know, if you go to Alibaba right now and type hydroform, you'll find a lot of machines there. We don't have any affiliations with Alibaba, as an example. So what we've gone and done is make sure that each of our product has a very unique code, so that should you have a maintenance issue and you call us, because it will be branded hydroform, we will ask for that code. If it doesn't have that code, then we know that it's not our product, unfortunately. So we've gone to the extent of taking legal challenges with Alibaba, but Alibaba is a huge giant. We can't tackle them, and it's an ongoing battle, you know. So, but that's how we try and make sure that we keep quality by endorsing the products that we work on. Yeah.
Great, that's brilliant. And then, I mean, obviously, if you're going to make an impact in this market, you've got to scale. And what are some of your initiatives that you're taking now to scale your product?
When we started 3D printing 4 years ago in Malawi, we acquired a machine from Europe, and we discovered that the machine was not really adapted to the African construction environment. The cost of acquisition of the machine was expensive, okay, and the operational cost was also expensive. So our first battle was to create a technology which is more African-made or African compatible. Okay, so we developed our own 3D printing technology, which is manufactured in South Africa, actually, which is quite funny because we cannot print there, but we manufacture the technology to make it more affordable and also more affordable in terms of logistic costs. So you don't require a crane to assemble the printer. A lot of incremental improvement. Okay. So our first fight was about the technology itself, the motion technology, we call it. Now our second fight, which is the most important, is the material. So today, the cost of the 3D ink, we call it the 3D ink, and basically it's concrete material, but we call it the ink, is expensive because you don't have the infrastructure, you don't have a lot of projects. We need to produce at scale and mass production to decrease the cost of the material. This is the first thing, and we need to have some technology which is compatible with cheaper ink. So, for example, in Africa, we started with mortar printing, and the mortar is an expensive material. And we are moving to concrete printing with bigger aggregates that will drastically reduce the cost of the material. And we, in the coming 12 months, we're going to be on par with conventional construction methods, or even lower than the conventional construction methods. Yeah.
Okay, so I think we've seen the benefits, and it's undoubtedly there are benefits. There are also huge challenges. What's interesting for me is that all four of us do completely different technologies, similar benefits and similar challenges. So it just shows that there isn't one path for alternative technology. If you can, just in sort of 30 seconds, just give me one area where you think, one strategy where some of these challenges, or how some of these challenges could be alleviated.
Sure, and I think that's very true. Every building method, and also that goes for our innovation, has certain application areas for which it's most suitable. For timber construction, for example, it doesn't make much sense to build in Sahel countries, where first of all the climate is not so suited for timber construction as the more tropical climates or moderate climates, and there's not much forest around in the Sahel, obviously. So that goes for every building method. Looking at the material sourcing, where does it come from? Is it does it make sense environmentally and cost-wise in that area? And also, how does the material behave in that climate, in that culture? I think that's most important. And then also, of course, the building typologies. We now focus mostly on detached single-story housing, because building that timber ecosystem requires to start with that, and then we can scale up to maybe high-rise timber, mass timber, but you need that ecosystem for that to manifest. So obviously that's a solution for peri-urban or countryside construction, which is still a large part of what we have to build anyway, but so we have to look at the typologies. We also have to do urban densification, for which we're probably going to need concrete for quite a while, even though we have to decarbonize that. Yeah, it's looking at where it makes most sense to innovate, scale in that sector first or in that application field, and then expand from there on where it makes sense, I would say.
Okay. And Mbuse, one strategy where you think our life could be made easier, whether it's regulatory policy. I know one thing we haven't spoken about is funding. I think funding for startups, government coming to the party is great. Those initiatives.
Thanks, Cheryl. I think definitely we need partnerships, and since we're at the conference that's about funding, finance is the most important part of this element, that we need financing for all these type of projects. And I'll give you an example. Shelter Africa, about over 10 years ago, gave us a challenge along with other alternative building technologies to develop a house in Nigeria, 2-bedroom house for under $5,000. We managed to achieve that and put that out in the market. But the project never took over and went further after that. And I'm sure that house right now, when I did the calculations, we're sitting now maybe at about $11,000. And that's all with electrical works and plumbing all done. So we need such collaboration between ourselves and the financing companies so that they can fund this together with the governments and making sure that we upscale. My hope and challenge is that next year, when the four of us sitting here, again, should be that we each are sitting with a project of about 10,000 houses that we need to deliver on this continent using the technology.
That would be amazing. Okay, so Ghislaine, last comment from you, just around one strategy that could make our lives easier. I mean, we haven't also, there's things about stakeholder education, how market acceptance, collaboration with architects and other partners as well.
Yes, I would say like collaboration within the industry between the architect, the developers, and the builders. That's the main point to, let's say, to roll out the technology. If you design a building with 3D printing from the initial design phase, you will benefit from the technology, but adapting a classic design, conventional design to 3D printing, the process is possible, of course, and it's okay, but it's just the mindset which is different. Yeah. So I believe like involving all the stakeholders in the construction industry. And the last word would be like R&D, a lot of R&D. You can state that the 3D printing technology, it's like automotive technologies, we are at the 1930s basically, so it's now scalable, we can roll out, we can produce, but we still need to do a lot of R&D to make the technology even more reliable and cheaper. It passed by R&D, yeah.
Great. Thank you very much, guys. I think we're out of time, and I don't think we have time for questions. Do we have time for questions? Yeah, I think if anybody does have questions, we'll be outside at tea and one. But thank you for listening, and I hope we've whet your appetites into what the alternative building industry is capable of. Thank you.